My name is Alex Sin, and I am an AI software solutions engineer at Intel. Today, I'm going to show you a demo on Llama Stack MCP servers running on Red Hat OpenShift AI, powered by Intel Xeon scalable processors and Intel Gaudi AI accelerators. Model Context Protocol, or MCP servers, act as a secure bridge between your AI systems, such as LLMs, and external tools, data, and applications. It allows your AI to access real-time information, search documents, query databases, and even interact with other software. While MCP servers are easy to use, the challenge comes in integrating them into an enterprise AI ecosystem with considerations to security, governance, and scalability. There are three key issues. 1. Insufficient authentication and authorization. AI agents might execute actions while accessing sensitive data that is not supposed to in the first place. 2. Agentic AI threats and supply chain vulnerabilities. Hackers might be able to manipulate AI agents in a way such that the tool descriptions are changed so that data is either leaked or stolen. It can also cause your servers to run on unvetted ones. 3. Deployment and operational challenges. Different teams use different tools, and as a result, the server management is fragmented, making it difficult to enforce enterprise-wide standards and policies. In today's demo, I'll be showing you Llama Stack MCP server. This will involve deploying Llama Stack and connecting with a vLLM with a model running, as well as 2 MCP servers. For vLLM, we are deploying a very small Llama 3.2 3 billion parameter model on both Intel Xeon scalable processor and Intel Gaudi AI accelerator. It will work on both depending on your compute availability and the size of the model that you want to run with. For the MCP servers, the first one is weather, which will do weather forecast and give you alerts. The second is HR tools, which allows you to query an employee's vacation balance, as well as create vacation requests. By running this on Red Hat OpenShift, it gives you enterprise-grade controls with respect to authentication, security scanning, as well as running the entire application in isolated containers. This will limit MCP servers' access to sensitive data and network resources. Now, let me show you the demo in action. First, I'm going to run it on Gaudi. This is what the UI looks like. We first have a very basic chat interface. Let me just try it out. Why is the sky blue? And we immediately see the output streaming on Gaudi. Now let's actually try using some of the MCP servers we have deployed. On the left-hand side, we have tools, and we have the 2 MCP servers as shown. We have weather and internal HR. Make sure to click on them to enable them. Let's try asking it the weather. What is the current weather in New York? As you can see, it uses the get forecast tool to retrieve that information from the internet. This is the current temperature of New York right now, and it also gives extra information about it. Now let's try out the internal HR tools MCP server. I'm going to ask it, what is the vacation balance of employee 1? You can see it uses a different tool now, and it gives us a summary like so. You can also create a new vacation request by entering it in the prompt. Create a vacation request for employee 1 for November 27th and 28th. And like so, It looks like it's created it, but it's pending approval. Now, let me show you what's happening underneath the hood. On the Red Hat OpenShift console, these are the different pods that are deployed for this application. You'll notice that the vLLM serving pod has HPU in its name. That is to help you know that it's running on Gaudi. You can go inside the YAML file to take a look at the specific details of the Helm chart, including the actual vLLM image that is used. For example, in this case, this is the image that we are running with. Likewise, you can run the exact same demo on Xeon. The difference is for the vLLM serving, instead of running on Gaudi, it's using Xeon to do so. Otherwise, the usage is exactly the same thing. And here I just want to show you an example output from the weather forecast MCP server, where I ask it a different prompt on what's the weather in San Francisco. On the Red Hat OpenShift console, this shows all of the pods that are running for this application on Xeon. You'll notice that the name for the vLLM serving runtime is CPU instead. Going inside the YAML file, you can also inspect the contents, and you can see that the image is actually different from the one we used previously. Intel and Red Hat are working continuously to provide the latest and best vLLM image to run your applications on Xeon CPUs so that you get the best performance for LLM inference. MCP servers are easy to use, but the challenge lies in integrating them into an enterprise AI ecosystem with security and scalability. You can do so by deploying MCP servers on Red Hat OpenShift. This gives you an environment that is managed, secured, and scalable for your enterprise AI workloads. To quickly get started, you can run the Llama Stack MCP server, which is a Red Hat AI quick start. This allows you to seamlessly deploy a model with vLLM, any MCP servers that you desire, and Llama Stack to connect them all together. You can run this on Xeon CPUs and Gaudi AI accelerators, depending on your compute availability and the size of the models that you want to run with. This will simplify your entire MLOps lifecycle and give you optimized performance in terms of LLM inference. If you're interested, you can run the Llama Stack MCP server on your own by going to the link that you see here on the screen. If you're interested in other Red Hat AI quick starts, which are essentially ready to run real business use cases to help kickstart your AI journey on Red Hat, you can check out that GitHub repo as well. Thank you so much for watching.